3 ways to evaluate a limit. Graph it, numerically, which involves looking at the table, and then analytically. This usually involves some sort of manipulation. Rationalize a numerator or denominator, factor, simplify with common denominators. Everything we did in the previous unit could show up here in this manipulation. So 2 forms that we need to recognize are indeterminate form, and there are many of them, but 0 over 0, infinity over infinity, infinity plus or minus infinity are some of the most common ones. And we're primarily going to focus on these 2 for the indeterminate that we manipulate. And then when we get an undefined answer, some sort of number over 0. Like if we evaluate the limit and we get 4 over 0. When I'm in this form here, I'm going to manipulate to evaluate the limit. When I'm here, I'm going to look at one-sided limits. Okay? So we've got 2 things that we're primarily doing. Manipulating, if we get 0 over 0, undefined over undefined, or looking at one-sided limits to see if we have a limit that actually exists. Our strategies for limits are going to be direct substitution first. Do we get an easy answer? Great, we're done. If not, if we're in this form, manipulate. If we're in a number over 0, look at one-sided limits. So let's look at an example. X cubed minus 27 over x minus 3. First thing we're going to do is direct sub. 27 minus 27, 0 over 3 minus 3, 0. So let's look at this guy on the calculator. Let's go up to 30. Let's look at the graph. And we're looking at 3. And you can see that there's the hole at 3. If we evaluate it at 3, we don't get an answer. It's tough to see. But we don't get an answer there. If we go to our table, we look at 3, delta O1. We can see at 3, we have the error. We can see that we're at 26.8, 26.9. Error 27.09, 27.18. So as we are approaching 3, we're undefined. 2.99, 26.9, 3.01, 27.1. The ways we've looked at it before, graphically, numerically, we see it's 27. But now we're going to do it analytically. So 0 over 0 tells me to manipulate. Rewrite my limit sign. Factor x cubed minus 27. X minus 3. X squared plus 3x plus 9 over x minus 3. Those minus 3's remove. Limit as x goes to 3 of x squared plus 3x plus 9. I can now direct sub that 3 in. 3 squared, 9, plus 9, plus 9, 27. So I remove the discontinuity. Once I take the limit, I stop writing the limit, and I get my answer. This guy, I plug in negative 3. Negative 3 cubed is negative 27 minus 27 over negative 3 plus 3. 0. Negative 54 over 0. Undefined. So now what? We've got a number over 0. We know this. We know this is a vertical asymptote. We know we got a vertical asymptote at negative 3. But now I need to look at the limits. So when I get a number over 0, the limit as x goes to 3 from the left of x cubed minus 27 over x plus 3. Negative 3 from the left. I'm going to evaluate the limit and I'm going to plug it in. Negative 27 minus 27, negative 54. A number that's a little bit smaller than negative 3 is going to give me a negative number. So over a very small 0, just like we did in the previous chapter. Negative 54 divided by a very small 0, a negative by a negative, is a positive infinity. Limit as x goes to negative 3 from the right. Negative 50, let's write that down. X cubed minus 27 over x plus 3. That will give us negative 54. A slightly bigger number than negative 3, like negative 2, positive, negative 2.9, positive, negative 2.9999, a positive 0. A negative divided by a positive is a negative infinity. The left does not equal the right. Therefore, the limit as x approaches negative 3 of x cubed minus 27 over x plus 3 does not exist. We need to look at the left. We need to look at the right. They don't agree. So we state the limit does not exist. First thing we do, direct sub. Root 2 minus root 2. 0 over 0. Manipulate. So we're going to multiply by the conjugate. Square root of 2 plus x plus the square root of x, square root of 2 plus x plus the square root of x. I don't know, it should be 2. Plus 2. Limit as x goes to 0. A minus b, a plus b, difference of squares. 2 plus x minus 2 over x times 2 plus 2 plus x under the square root plus the square root of 2. Limit as x goes to 0. 2 plus x minus 2 is x over x times 2 plus x plus root 2. There's my removable discontinuity. X cancels x. Now I can do my substitution. I'll rewrite it one more time. X goes to 0. 1 over the square root of 2 plus x plus root 2. Now I'll sub it in. 2 plus 0 is square root of 2 plus square root of 2, which equals 1 over 2 root 2. We can leave it like that. So 0 over 0 tells me to manipulate. Okay, multiply to rationalize the numerator. When we do, it gives us something that can be removed. Anytime I manipulate, I should be canceling something out and removing that discontinuity. Removing that gets rid of my 0 over 0, gives me the ability to get an answer. Let's look at 4. Same way.
Thank you. Wait, how does...
Direct sub gives me 1 over the square root of 0, which is 1 over 0. Right? Now, I might be tempted to rationalize it, but look, if I rationalize it, I will get square root of x over x, which is 0 over 0. Which what? Now am I going to rationalize the numerator and come right back to this? So it really wouldn't send me anywhere, right? Recognizing a number over 0, left and right-sided limits. Limit as x goes to 0 from the left of 1 over the square root of x is 1 over the square root of a very small negative number. Can I take the square root of a negative number? No, right? It doesn't exist, right? Doesn't matter how small it is. This guy doesn't exist. Now we're probably done, right? But we should look at the right side anyway. So 1 over square root of x on the right side at 0 is 1 over the square root of a very small number, which is 1 over a very small number, which is a very large number. Does my left agree with my right? No, it does not. Therefore, the limit as x goes to 0 of 1 over the square root of x does not exist. All right, direct sub 1 over 4 minus 4 is 1 over 0. This tells me one-sided limits. Limit as x goes to 16 from the left. Limit as x goes to 16 from the right. A little bit less than 16. Square rooted is going to be a little bit less than 4. So 1 over a slightly smaller number than 16 minus 4. Right? Now if 16 is 4, a little bit less than 16 is a little bit less than 4. A little bit less than 4 minus 4 is a small negative. And 1 divided by a small negative is a large negative. 1 over a slightly bigger number than 16. Now, a way bigger number than 16 would be 25. 5 minus 4 is 1. Positive, right? Slightly bigger is going to be like 4.01. We just plug that in, and we say, oh, okay, that's 1 over a positive 0, which is a positive infinity. Left does not equal the right, so the limit as x goes to 16 of 1 over the square root of x minus 4 does not exist. All right, and the last one, rational function, get a common denominator. This question should look familiar. We've seen it in previous chapters. So now we've got 2 minus 2. Don't forget to distribute the x, the negative to the x, over common denominator, all over x over 1, limit as x goes to 0 of that, which equals the limit as x goes to 0, 2 minus 2, 0, negative x over 2 times 2 plus x multiplied by the reciprocal times 1 over x. Isn't that nice? There's our removable. Those guys are gone. Which equals the limit as x goes to 0 of negative 1 over 2 times 2 plus x. Now I can evaluate it. I will get negative 1 over 2 times 2 plus 0, negative 1 over 2 times 2, which is negative 1/4. So I get 0 over 0. I manipulate, in this case, rational function, get a common denominator, simplify it, find whatever cancels out. There's your removable discontinuity. Now that I've removed it, evaluate it, get my answer.